Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to geometric rotations. We are going to be doing this some with coordinate geometry, some without. But the big idea is that we are going to continue to use the grid paper, and that way it can help us out. Very big deal. So rotations are going to be exactly what they sound like. You're going to spin something or you're going to turn it. Most of the time, we are going to turn counterclockwise. Unless you're told different, assume counterclockwise. There's a reason for that. It has to do with basically mathematicians where they consider true zero to be and that they go counterclockwise from there. So it is a rigid transformation, meaning that everything's going to have the same angle and side length. And technically it is constructed by copying an angle. Okay, so what's going to happen is you're going to say you're going to have triangle ABC. We'll put C here. And they're going to give you darken that. They're going to give you a point P. And we're going to rotate 75 degrees around it. So the way that they're going to say that is lowercase r 75 degrees comma P. Okay, so step number one. We are going to connect every single line to P. You're going to do that in pencil. And sometimes it's easier to do them one at a time. I'm going to go ahead and do them all three. Okay. And then we're going to need to rotate that direction 75 degrees from each of those three lines. Okay? Well, 75 degrees is not perpendicular, so I can't just draw a perpendicular line or anything like that. So what I have here is a app that just has the angles, right? So I'm going to line up with my key being right here. And it's better if you have an actual physical protractor. Just didn't happen to have one here at the house today. Okay, and we want this to go from here to 75 degrees, right? So what I'm going to do, since I don't have an actual protractor, is I am going to get a piece of paper and I'm going to fold it to that size. That way I can copy the angle. So this is just something you can do should you not have it. So right now my fold is too big. Come back here. Come back to the 75 degree mark. Now you might notice that there's numbers on the outside and the inside. The reason this is 75 degrees is that is 0 right there. Actually, watch this cool trick. We can see through, right? So I've got this line right here. Put you back at 75. There we go. Now I know how to make my fold. Okay. We'll clear the extra paper out of the way. And now we're left with that 75-degree angle. Okay. You can even re-verify it. By going, all right, did that actually work out right? And it looks pretty solid when I'm not shaky. Okay, so getting a protractor is the better thing, but we used a piece of paper to make our 75-degree angle. Now we need to go from P 75 degrees down, right? And I'm going to draw that new line. Then from PA 75 degrees down. And from PC, we need 75 degrees down. So I like folding a piece of paper because then I don't have to remeasure it 3 times. Okay, then we're just going to take a compass and we're going to widen it out. There we go. And again, that was our B because it was rotated 75 degrees. Now we need to rotate 75 degrees to get our A, which A is further out, so widen this back out. Now we have our mark and our mark. So now we have our A value. And then we need to do our C by rotating it 75 degrees to that mark, and it's closer to P, so I get to rotate this thing back in while I'm doing is spinning my wheel. I love a good compass. It really does make geometry easier when you can see what's going on. And the reason I say a good compass is there's some that just don't hold because they flex in and out without this wheel really keeps you in spot. There's our new C. And so now we have our shape that has been rotated 75 degrees. So again, we connected the line, we drew our 75-degree angle, we copied the distance. And again, a compass, this kind of compass, and a protractor are amazing things. Straight edges, I don't actually like to measure with a ruler because I think a compass is faster. So this was over a random point. Okay. What happens if you want to rotate 90 degrees around the origin? So R, 90 degrees, comma, O. Well, 90 degrees is perpendicular, so that's actually really easy for us. Because we've talked about the slope of a line. So here's point A, and it's at 1, 2, 1, 2, 3, 4. Okay, now I'm going to cheat a little bit with this one because we know certain things happen. So connect it, right? Now I needed to go 90 degrees. 90 degrees is perpendicular, so I could just kind of come in here and use my mirror case. But I know perpendicular has, I know how the slopes relate. So this is 1, 2, 3, 4, 1, 2. So a slope of 2 over 1. So I know this other one needs a slope of negative 1 over 2. I happen to know that the new A is going to be right there because this is 2, 4, so this is 4, 2. Okay, but in case we don't believe me, where's that compass to check our size? So we can follow those same steps. Got to bring it down, right? So perpendicular is really nice because we can just use our slope when we're comparing to the origin. Absolutely, it was right there. So we're at -4, 2. So notice how the x became the y and the y became the x, and we changed signs. So for a point, A comma B, if you rotate 90 degrees around the origin, it will become -B comma A. And that's going to happen every time, just due to the perpendicular slopes and how perpendicular slopes work when in association with the origin. So if we had an entire triangle, we could do that pretty quickly. If you were to rotate 90 again, okay, so let's think about that. So if we rotated A comma B, I use capital A versus lowercase a. If we did that and we did a rotation 90 degrees around the origin, then we would be at -B comma A. What if we did that and we did, this would be A prime. What if we did a second time, again 90 degrees around the origin? Then we'd have -A comma -B. And if we did it a third time, we would have B comma -A. So it just keeps repeating what's happening, okay? Change that out for xy, -yx, -x, -y, and y, -x. So you can repeat these over and over again, but isn't 290 a 180? So I don't prefer to necessarily do the coordinate geometry based off memorizing these little things. I like to really think about my actual shape, and I like to see it. So we're going to rotate this one 180 degrees. And again, I like to do it visually. I don't like just doing random coordinates because I don't feel like that gives you the true understanding of what's going on. Plus, what if you forget, oh, do I change this sign or do I change that sign? Oh no, help. So I don't want to worry about that. So make sure we go 7, 6, 5, 4, 3, 2, 1. I didn't want to go too short. I wanted to make sure I could get B on there. Okay, so A is at 3, 5. B is at 1, 7. C is at -2, 4. And D is at 2, -1. We have a quadrilateral. And I want to rotate 180 degrees around the origin. Okay, well the good news is 180 degrees is a straight line. So as long as I draw a straight line from each of these through the origin, I'm great. All right, so D. C. A. And B. And let's hope that I drew straight, that I wasn't off a smidge. Okay, so we could measure each of these, or we could think about them in like triangles. So I could come over here and go, A is right 3, 5. Or I could go left 3 and down 5, which happens to be where this is. 1, 1, 2, 3, 1, 2, 3, 4, 5. Should do that in a different color, shouldn't I? So that means since D is 2, 1, we should be doing 1, 2. C was negative 2, 4, so we're going to go 2, negative 4. And B was 1, 7, so we're doing negative 1, 1, 2, 3, 4, 5, 6, 7. We get our A, B, C, D. Now, it looks like somebody has taken this and went 180 degrees. You'll notice D went through 2 quadrants, 1, 2. Why? Because 180 degrees is half a circle. So if you think about the circle here, yes, we did half a circle. If we did half a circle here, yes. Remember, the origin is our center. So we can actually see that A became left 3, down 5. B became down 1, down 7. Sorry, right 1, left 1. C became right 2, down 4. And D became left 2, up 1. So when you're rotating around the origin, especially if it's a 90, a 180, or 270, your numbers are going to hold pretty well. They just might flip-flop. They might change signs, things like that. Okay, now, if we would have, instead of rotating it, if we had reflected the A over the Y and then over the X, we would have gotten here. Reflect the C over the Y over the X. Reflect the B over the Y over the X. Yeah. Any rotation is a combination of 2 reflections. So, and that can be done with any of them. So any rotation is a composition of reflections. But they have to, the reflection lines have to intersect at point P. So let me give you a picture of that. Okay, so again, any rotation is a composition of 2 reflections. So here we go. A can rotate to here, right? This is 40 degrees between here, 80 degrees between here. Okay? So as long as the angle is half the reflection angle. So the reflection angle here is 80. This is 40. When I talked about the other one, it was a 180 degree reflection, which is why I had to do 2 90 degree reflections. To get an 80 degree reflection, you have to do 2 40 degrees. Okay? So the quick reflection and reflection, as long as your angle is half of that angle. So that's just a fun relationship that rotations are also reflections. Can you do it straight on reflections? Yes. Can you do it with double rotations? Absolutely. The choice is which is working better in your particular scenario. So keep that in mind. I honestly like just being able to draw to my point of rotation and then just copy the length over. Draw to my point of rotation, copy the length over. Draw to my point of rotation, copy the length over until my shape is done.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.